chemical calculations procedure to solve problem 1 in the red booklet. On the right-hand side of my screen, you see the correction model that you also find on page 24 of the red booklet. So we start reading the question, and it says, in the reaction between methane and copper 1 oxide, the substances copper, carbon dioxide, and water are formed. So step 1 of the chemical calculation is to create the balanced reaction equation. And you have done this before, so I'm not going to linger to explain. Here you find it, and you see that 1 molecule of methane will react with 4 molecules of copper oxide to form 8 molecules of copper, 1 molecule of CO2, and 2 molecules of water. The question then is how many grams of copper oxide are needed to allow 5 grams of methane to react. So you see that first of all, that you combine actually 2 steps. In my procedure, I say to calculate the MR values first. You have to do that for the substances that you need in your calculation. So it's smart to go on to step 3 and see what is the mass given and the mass asked. The mass given is 5 grams of methane, written below the CH4 in the reaction, and asked is the amount of copper oxide. So I only calculate the MR value of methane and of copper oxide, and you see here how I do that. 12 plus 4 times 1 is 16 gram per mole, and here I've got 2 times 63.5 plus 16, and it equals 143 grams per mole. Then step 4 is to calculate the amount of moles available. So I go from 5 grams and I divide that by 16 grams per mole. You can see here that just by using the dimension analysis, I write down my units, I can easily see, oh, okay, it's grams divided by grams per mole. The grams fall away, the 1 per mole at the bottom of my fraction remains, so I get, I'm left with mole. And that amount of mole of methane equals 4 times as much mole of copper oxide. How do I know that? That I know from step 5, mole ratio, and I need to see the balanced reaction equation, so the big numbers. So I go and I see that 1 mole of methane will react with 4 moles of copper oxide. And so I write down my mole ratio above, just to be very clear. And then I could go on above here, but that doesn't really fit. So I go on below here. So I calculated that 4 times as much mole, I get 1.25. And then step 6 is I need to go from, so I calculated the mole used and mass, and then I need to calculate the mass of the mole used or the product used, and I calculate that by multiplying mole times gram per mole in order to calculate the grams. That's the mass, and I do that again with dimension analysis. Mole times gram per mole, that means that the mole falls away, leaving me with the grams. I could also do this with a ratio table, which I haven't done here. And if you want that, please just send me a message and I will work that out for you. So in this video, as said, we have looked at problem 1. There's a very visual representation in the correction model, and in this way you can follow steps 1 to 7 from the chemical calculations procedure.